students, welcome back to question number 7 in triangles. So let's have a look at the question. This question is a bit confusing, so please read it carefully. Let's get into it. Consider a square ABDF. So the numbering is not very normal, looks a little odd, but that's what it is. ABDF, that's what they had given. That's a square we have. In that square, we have to prove that area of an equilateral triangle described on one of its sides. So this is a side AB. On that I am describing one equilateral triangle whose area has to be equal to half the area of equilateral triangle described on one of its diagonal. This is what it says. I'll reread it once again. What is that we have to prove? There are two equilateral triangles. One equilateral triangle is described on one of its sides. So let's say AB is a side, on that we have this triangle ABC. This is one triangle I have. AB equal to BC equal to CA. This is one triangle which is described on one of the sides. And we have another triangle, equilateral triangle, which is described on one of its diagonal. Let's say AD is a diagonal. On that AD I am describing this triangle. So AED or ADE triangle. So where AD equal to DE equal to EA because it's equilateral. So we have these two triangles. One is described on the side, the other one is described on one of the diagonals. We have to prove that area of ABC is half the area of ADE. That's the question. So I hope you understand the question. Otherwise, you just go back to it once again and read it. Once you understand the question, the solution is not very tough. It's very straightforward. Let's get into the solution part. So first concept that we are using here is in a square, length of the diagonal equal to root 2 times the length of the side. That's a concept, simple concept. It's simply Pythagoras theorem. You see that ABD is a right angle triangle. So AD square has to be equal to AB square plus BD square. Alright. And then AD equal to BD, let's say A, both of them are A, let's say in a square all the sides are equal, right? So A square plus A square will become 2A square, and you apply root either side, you get AD equal to root 2 times A. That's the value of AD. We got it. So that's first concept. Now let us go to the second concept where it is about the area, because they're talking about area, right? And you should know this formula, that area of an equilateral triangle, I use a symbol delta for area. Delta is meaning area. That's the symbol I'm using here. So delta equal to root 3 by 4 times side length square. This is a formula. I'm not going to explain this formula now. We'll take up some other video if required. But every student should know this formula. Area of an equilateral triangle equal to root 3 by 4 times square of the side length. So don't worry about the root 3 by 4. We are just focusing on that proportionality here. We know that area is directly proportional to side square. That's a proportionality we have here. So ratio of the area they are talking about. So ratio of the areas. Area of ABC by area of ADE equal to side of AB square divided by side of AD squared. AB we have taken as A, then AD was coming out to be root 2A. Just take the ratio and then square it. You get the A gets cancelled out and you get 1 by root 2 whole square, which is 1 by 2. So the area ratio is 1 by 2, and that is what they're asking. So with that, the solution is completed. Thank you very much.